Our Earth is always moving. It's a dynamic, ever-changing sphere, constantly in motion, spinning on its axis and orbiting the sun. This perpetual motion is a fundamental aspect of our planet's existence. It spins like a top, rotating at a speed of about 1,000 miles per hour at the equator. This rotation is not just a simple spin, it's a complex dance that has been ongoing for billions of years, making one complete rotation every 24 hours. This consistent rotation is what creates the cycle of day and night, a rhythm that all life on Earth has adapted to. This rotation is what gives us day and night. As the Earth turns, different parts of the world experience sunlight and darkness, creating the beautiful transitions of sunrise and sunset. We barely notice this constant motion, like passengers on a train gliding smoothly along its tracks. The Earth's rotation is so smooth and consistent that we live our lives without ever feeling it. Before we dive deeper into this extraordinary scenario, make sure you subscribe to TechUniverse. We bring you mind-blowing insights into science, technology, and the universe every week. Hit that subscribe button and join our journey into the unknown. But what if this train suddenly slammed on the brakes? Imagine the chaos and confusion that would ensue if a speeding train came to an abrupt halt. What if our planet, instead of spinning through the cosmos, were to just stop? The idea might seem far-fetched, but it's a scenario worth exploring. It might sound like the premise of a science fiction film, but the implications of such an event are firmly rooted in scientific reality. Scientists have pondered this hypothetical situation, and the results are startling. The consequences, as we'll soon discover, would be nothing short of catastrophic. From massive earthquakes to devastating tsunamis, the sudden halt of Earth's rotation would unleash a series of natural disasters that would reshape our world. The atmosphere, which moves along with the Earth, would continue to move at the same speed, causing unimaginable winds and storms. The sheer force of these winds would be enough to flatten cities and forests alike. Ocean currents and tides, driven by the Earth's rotation, would be thrown into disarray. The sudden stop would cause massive tidal waves, flooding coastal areas and altering marine ecosystems. The Earth's crust, made up of tectonic plates, would experience immense stress. The sudden cessation of rotation would likely trigger widespread volcanic activity and earthquakes, further adding to the chaos. Wildlife and natural habitats would be severely impacted. The sudden environmental changes would disrupt ecosystems, leading to the extinction of many species and the collapse of food chains. Human civilization, with its cities, infrastructure, and technology, would face unprecedented challenges. The sudden halt of the Earth's rotation would bring about a new era of survival, where humanity would have to adapt to a drastically changed planet. While this scenario is purely hypothetical, it serves as a reminder of the delicate balance that sustains life on Earth. It underscores the importance of understanding our planet's dynamics and the need for global cooperation to address potential threats. For now, we can take comfort in the fact that our planet continues its steady rotation, providing us with the stability and predictability that life depends on. The Earth, in perpetual motion, remains a testament to the wonders of our universe. To understand the chaos that would ensue, we must first journey back to the very beginning, to the birth of our solar system. This journey takes us back billions of years, to a time when the universe was still young, and the building blocks of our solar system were just beginning to come together. Billions of years ago, a vast cloud of gas and dust, known as a nebula, swirled in the emptiness of space. This nebula was a chaotic and dynamic environment, filled with particles and gases that were constantly moving and interacting with each other. The nebula was a birthplace of stars, a region where new stars were being formed from the raw materials of the universe. This cloud, under its own gravity, began to collapse in on itself. The gravitational forces at play were immense, pulling the gas and dust inward, causing the nebula to shrink and condense. As the nebula collapsed, it began to heat up, and the pressure within it increased. This process of gravitational collapse was the first step in the formation of our solar system. As this material drew inwards, it began to spin faster and faster, much like a figure skater pulling in their arms during a spin. This increase in rotational speed was due to the conservation of angular momentum, a fundamental principle of physics. As the nebula continued to collapse, it flattened into a spinning disk of gas and dust, with the material in the center forming a protostar, the early stage of a star. This spinning motion, a consequence of the conservation of angular momentum, is what ultimately led to the formation of our Sun and all the planets, including our own spinning Earth. The spinning disk of gas and dust, known as a protoplanetary disk, was the nursery of our solar system. Over time, the material in the disk began to clump together, forming planetesimals, the building blocks of planets. These planetesimals collided and merged, eventually forming the planets we know today. The Sun, at the center of the disk, ignited and began to shine, providing the energy needed to drive the processes that would shape our solar system. The birth of our solar system was a complex and dynamic process, driven by the forces of gravity and angular momentum, and it set the stage for the formation of the planets and the development of life on Earth. Now, imagine that spin grinding to a halt. The Earth, which has been rotating at a speed of roughly 1,000 miles per hour at the equator, suddenly stops. This unimaginable event would unleash chaos on a scale never before seen. The immediate consequences would be felt on a global scale. The sudden cessation of the Earth's rotation would result in catastrophic events that would affect every corner of the globe. Cities would be thrown into disarray, and the natural world would be upended. Everything on Earth's surface, from the air we breathe to the oceans that cradle our continents, is moving with the planet's rotation. This movement is so ingrained in our daily lives that we hardly notice it. But if the Earth were to stop spinning, the inertia of these elements would continue to propel them forward. A sudden stop would be like a cosmic car crash, with everything on the surface continuing its eastward trajectory at hundreds of miles per hour. Imagine the sheer force of this movement. Cars, buildings, and even the ground beneath our feet would be thrust forward with incredible speed. Buildings would crumble, trees would be uprooted, and colossal tsunamis would surge across continents, reshaping coastlines in their wake. The force of these tsunamis would be unlike anything we've ever seen, capable of wiping out entire cities and altering the geography of our planet. The very air we breathe would become a supersonic wind, scouring the Earth's surface with unimaginable force. These winds would be strong enough to strip the land of its topsoil, destroy forests, and flatten buildings. The devastation would be total and complete. In the aftermath, humanity would be left to pick up the pieces. Emergency services would be overwhelmed, and the global response would be one of shock and disbelief. The infrastructure we rely on would be in ruins, and the task of rebuilding would be monumental. Scientists would scramble to understand the event, analyzing data and trying to make sense of the unprecedented disaster. The global scientific community would come together, pooling resources and knowledge in an effort to comprehend the full scope of the catastrophe. Amidst the chaos, there would be stories of hope and resilience. Communities would come together to rebuild, adapting to the new reality and finding ways to survive in a changed world. The human spirit, though tested, would endure. Over time, the Earth would begin to recover. Nature has a remarkable ability to heal, and slowly, the planet would start to show signs of new beginnings. While the scars of the disaster would remain, life would find a way to move forward. The long-term effects of a stationary Earth would be equally dramatic. The centrifugal force generated by Earth's spin is what gives our planet its slightly squashed shape, with a bulge at the equator. Without this force, the oceans, no longer held outward, would migrate towards the poles, drowning vast swaths of land. This shift in mass would have a profound effect on Earth's gravity, making it unevenly distributed across the globe. Imagine a world where the weight of an object changes depending on your location. Perhaps the most striking change would be to our experience of day and night. With no rotation, one side of Earth would be perpetually bathed in sunlight, while the other would be plunged into an endless night. This division wouldn't be as simple as a line down the middle. Instead, a narrow band of twilight would exist between the day and night sides. This region, a perpetual sunset, would experience a strange, dim existence, neither fully bathed in light nor completely shrouded in darkness. The consequences of a stopped spin extend far beyond our planet's surface. Earth's magnetic field, generated by the movement of molten iron in our planet's core, would also cease to exist. This magnetic field acts as a shield, protecting us from harmful solar radiation. Without this protection, the solar wind, a stream of charged particles constantly emitted by the sun, would strip away our atmosphere, molecule by molecule. The once life-sustaining air we breathe would be lost to the vacuum of space. The cumulative effect of these catastrophic changes would be devastating for life as we know it. The extreme temperatures, lack of breathable air, and constant bombardment by solar radiation would create a hostile and unforgiving environment. While some extremophile organisms known for their ability to survive in the harshest conditions might find a way to cling to existence, the vast majority of life on Earth, including us, would not stand a chance. The good news is that this scenario is highly unlikely. Earth's rotation is the result of billions of years of cosmic evolution, and there's no force at play that could bring it to a sudden stop. The laws of physics dictate that an object in motion will stay in motion unless acted upon by an external force. While there are forces acting on Earth, like the gravitational pull of the sun and moon, these forces are not strong enough to stop our planet's spin. They cause a very gradual slowing, but nothing that would bring it to a complete halt. Our planet's rotation is a testament to the delicate balance that governs our universe. It is a force that shapes our days, our nights, our seasons, and ultimately, our very existence. The next time you feel the warmth of the sun on your skin or marvel at the vastness of the night sky, take a moment to appreciate the wonder of Earth's spin. It is a constant, a reminder of our place in the cosmos, and a force that, thankfully, shows no signs of abating.